today we are so honored to have the second lecture from Mr. Konrad Fischer. And this lecture focuses on conservation design. And I think most of the students are either conservation students or master students focused on architectural history or conservation. And as we know, conservation, there's many kind of work related to conservation. But for design, there's several levels, from the policy making to conservation plan and to conservation design. And for architects, I think the third one, architecture design, could be the most difficult and the most interesting part. So why it is interesting and why it's difficult? Because there's too much things to deal with. And we have the conservation object, which has a history, and we must know the tradition to finish the conservation, and we must integrate the object with modern life. So it's very interesting. And I think Mr. Konrad Fischer will use a lot of cases. In the last 35 years, it has finished more than 450 projects. Yeah. And through these projects, we can see how he deals with these complicated objects. Thank you.
Thank you very much. I say Patrick Sangpeng. It's a great honor to me to stand another time here and come in contact with you, Chinese students and professors, about my real topic, how to rebuild, how to rehabilitate, how to conserve and how to preserve historic buildings. And to come to the point, the 450 projects I have finished and about 20 or 25 new buildings, what I designed. The main thing for my clients was that all the projects, besides two in the beginning, had been just in the budget. So I was responsible for the financing, and this was the only reason that I got the job, because the clients or the Office for Preservation, the governmental office, they know that if I will do the project, is a very big chance to be in the budget. So my topic is not so much philosophical. How shall we do it in architectural way or in conservational way? I will speak about it, but the main topic for me and also my clients is how do it in the budget and how do it with less money than new buildings, also if it is ruined, the project. And I will show you cases of my work to discuss and to present the methods, the systems, which can give everybody the chance to make with very few money a big thing, so that you can understand what I will telling you. My clients, 80% are privates, and normally private clients will not like go to architects. They would prefer to go to the firms and have the whole work done. And why did they come to me? First, the first 20-25 years of my business life, I got recommended. I got recommended from the officials. They know my work, they know that they can trust in my work, and I will make it in the budget, and it's quite good. So I got the recommendation, but I will not have the honorar I need for my work. So I'm always also in low budget with my honorar, and it was very hard to survive this situation. So after 25 years I found the way to get out of these problems, and now the clients come from themselves because they want the economical skills I can give to them. So they have very problematic projects with no money, and I can help them to get the grants, and I can help them to control the financiation, and so they will come from themselves. But how will they know me? They go to internet, and there they give in their problems in the search machine, and my website responds, and then they get in contact with me. They can read my opinion, and it's nearly all the time just the opposite of the mainstream, and they like it. Because in my website I will not report my projects and offer my service. I'm mostly discussing the problems they have and show solutions and show what doesn't work. And that convinced my clients, and so they phone me, and so I come in projects where I can make the price, a fair price. Not a very expensive price, but a fair price. So that is how I come to my projects. And in the moment, as I tried to get the minimum fee, which is regulated in Germany by a legal order, in that moment where I tried to get the minimum fee from our legal honorar, the recommendations shut. The recommendations from the officials, which are responsible that all is legal, but they will not pay the legal tax to the architects. And in that moment where I must do it to survive, they will throw you outside the system. That's Germany. To know where I'm coming from, we are here, China, that's Germany. And in the middle, I'm living. That's Germany. Here is Bavaria, and here is Hochstadt. You can translate it as high city. But in reality, it's a village at the River Main, where also from 200 kilometers further is Frankfurt. It's the upper part of the Main. It's very little river there. And here is a little mill. I'll try to show here. It's a Baroque water mill of a monastery. This is my office. Near the riverside, the water mill. That's our lake. And we have here 3,000 inhabitants. And my home village is here. Here is Hochstadt. And here is Schwörbitz. And we have here 1,700 inhabitants. And 6 of them are here. So, just far away. Germany is world champion in restoration, and that's Nuremberg, 1945. And you can imagine a lot of work. And just the last year, or some years ago, comes in the media how happy architects in Germany had been by the bombing. And they give posters, and they are happy to have a lot of work, and they will renew whole Germany after the modern Bauhaus style. That's Germany, 1945. And nearly all my private clients must make do-it-yourself to finance a project. And I ask you, what do you learn about do-it-yourself from your client? How to manage it? How to plan it? What shall he do? That's the industry. IMMONet, it means real estate net. Quicker, better residencing, living. In 5 minutes, this is a building place. That's advertising. So that's a problem. Making money on the ground or the old building. And all people in Germany think, or the most think, it's not worth. It's too expensive. We have not the money to rebuild, to renovate. It's a too expensive thing. And so most normal people don't want to renovate, even if they have the money. And my clients, mostly, they have not money at all. And so the first step is to get them the money to make the restoration. The architects, that's from a display case in GDR, former GDR. It's from the architect chamber in Halle before and today. That's the idea of architects in Germany, to make it better life. And if we look a typical old building in Germany, which has been forgotten by the architects and forgotten by the bombs. Does this building need an architect? Really? Does the people who live in this building, do they need an architect? Will they afford what he needs? Here's a hole in the floor that is toilet. What he needs is a plumber, but not an architect. This was my first building after study. I have learned to make big buildings, but to come to the reality, I didn't know how to build. I can make wonderful plans, but the craftsmen, what do they? When I go out of my study, I did not know how to build, how to construct, how to manage the building place. And you know, in Germany, I have the responsibility from the beginning, from the financiation on to the end. All the money goes through my hand to the craftsmen, to the civil engineers, and so on. So we have a big responsibility. But we have learned nothing from this in study. What we have learned is to build concrete buildings in very modern style. What no one told us is the corrosion of all this in very few years. That's a famous Munich Olympic Center. So much architectural prizes. But only 10 years later, all is rotten, and now they knock it down. The very famous Munich Olympic Center. That's in Gothenburg. Also the Swedish architects, they learn nothing from construction, from the real aging of the materials. They have not even an interest. They have only interest in the papers and in the lines on the papers. And they have theories about it. But the theory and the praxis of material, it's not interesting, it's boring. That's also very famous. The Holo Memo in Berlin. Rotten. The next year, after the vernissage, all is cracked. And they wrote before big articles in our magazines how they look for the perfect concrete. But a year later, 50%, and now I think 95% of these monumental blocks are cracked and bleeding out. What we learned is to give much concrete in the old buildings. That's in Jena, the Red Tower, a medieval tower. They have to rebuild, to renovate, to make it better. And as they changed the lintels of the windows, which had been only by masonry and by rendering, they changed it to make it better against real natural stone lintels. Then all cracked down, and 4 craftsmen are dead. That is what we learned. And they had one of the most famous static engineers for this work. It's not enough only to have the numbers on the paper. You must understand. And so, what have we learned? I studied Denkmalpflege, what is conservation. I studied in Munich. But did I learn how to manage an old building? No. I learned how to make a new building at the old place and to make new project in the old. And so we take everything out, we architects, what is against our draft, our new build draft, and away with all the history of the building, and then we have only the facade, and then we can do conservational work. That is what we have learned. History, preservation, national heritage is faked. I show you the tombstones of the German minority from now Poland. It's in Poland, I visited. And the restaurators, they did coating about the German inscription, that the new Polish inhabitants will not notice that all was German before. So I think conservational work is a lot of fake, and we must be objective. We must look for the objective position. That's a part of my work. Actually, we repair this building. It's a monastery for Benedictine monks. This I will show a little later. It's the orangery in Berlin. And although modern buildings, very old buildings, interesting, modern, historic, that's my daily work. And some pictures we will discuss later, some of them before and after, before and after, before and after. That's my work with not so much money as a new building at this place. And I will tell you how this works in my office, in my work. We start with this. The late Gothic framework building get 2 new axes in Baroque time. And the Baroque architects, they know nothing from construction and make Baroque axes in the medieval structure. And by this, they damage a lot of the structure. And after Second World War and some years later, as the refugees go out, this building stands empty. And when I start, it is a complete ruined building. On the other side of the river, they destroyed the whole quarter, and an architect from Hamburg built a new big house, a residence for students. That was the architectural price to do very good in the old history, in the old ambiente, in the old atmosphere. But no one will go to this house. This was a moment when I decided to make my civil engineering in my own office. I took a civil engineer in my team, and from this moment I do my whole engineering in my own office. Why? Because all the years before, it was my biggest struggle, it was mein Kampf against the civil engineers. They will not understand what is preservational work. They have no respect from nothing, and they don't understand anything from the structure. And then the best are the engineers for heating, for electricity. It is as if they even don't know what is a building. They have their lines, and if the lines work in the building place, it doesn't bother them. So the whole work to bring in the techniques, we must do live. Live, because it was not planned. There were figures on the paper, but it doesn't work. And so I decided to make it self for my own projects. And here we developed a binding of this rotten building. We binded it with metal stripes. I hope you can understand my school English. 80% I have forgotten. If you don't understand, please give me a sign. My daughters speak better English than me. So we bind it in all niveaus, the rotten substance. We didn't do outside the dry rot wood. We let it in because it's not necessary to take it out. If in future the building, the wood, is in dry situation, in dry milieu, nothing will happen. And if you do it out and have new wood in it, and even if it's poisoned by modern poison against rot, it will be rotten if the milieu is okay. So I say, let it inside. And we give new shape about all surface. We bind all together, also in this niveau. And so I can calculate with my civil engineers, all is good, all is good. It can come snow, wind, persons, all works. The old building has the old strength, the old ability to hold on all the stress. That's a trick. And on the metal wiring, we give Chinese material, the reed. And the reed is an underlayer for the rendering. And here is the situation, first the wiring and then the reed. And in the end will come the new render. And so the lintels from wood, we just changed a little bit outside. And then we have to renew only the inner parts of the lintels in wood, so that we can reuse 80% of what we found here. It's here again. And a new lime wash. The owner of the building must give some own work in it. And I'm very sorry to commit. He made the roof. And so it was not possible for me to preserve the old tiles, what I normally do. So this is new. I must commit. And we have a new surface. We have no patina there. But you must understand, who will do this work? as a responsible architect with lower money than a new building at this place. How can I do this? In my study, I have not learned. This is this building. But my luck was my first project. It's here. Just on the opposite, I did the same work with a house which was not so strongly destroyed. It was also from medieval time, but has a facade from Baroque done by masonry, not by destruction of the Baroque architect. And so, when I do the work here at this place, I always looked to the other side of the river and said, maybe this house will come to me sometimes. And it comes. So let's tell a little bit about my first work. You must know my father had been architect. And in the end of my youth, I decided to be also architect because it is so easy to go to the office of the father. But my father died when I had been in the third year. And from since I had 30 projects from the starting. And every Friday I had to go from Munich to my home, 300 kilometers, to do the work. And to have some architects as employees, which will go away with the next best project. And I cannot control it. That was my starting, my beginning. And I decided, after 1 year, after my finishing of study, I got invited to make it, and so I decided to try it, to go to the Office of Restoration in Munich, to make a scientific volunteer there for 2 years. And they give me the chance to go at home, to order my work, every Thursday in the evening. So I have a Friday every week to manage my office with 30 projects. And I must do all by myself. I have not a teacher. My professors cannot tell me anything what is worth to tell, to make. And so I started by experiment. And I think it's the best way to come in a work. Do it by experiment. So this was the other side before. And they argued, is it a monument or is it not? Is it heritage? Shall we protect it or not? And so they first took the very famous civil engineer and he shall make expertise. And from this expertise is this photo. Inside the water comes down and the very famous civil engineer gives his expertise and says, the main beam is broken, but all these holes he does with his hammer. And here we are at the top of the roof, and he is writing the main beam here is missing. But what he doesn't know, never had been a main beam at this place, because the roof system is just another. So he found a lot of damage. That's the expertise. And so he says we must correct all walls which are more than 1% out of the line. And he says we must give a moisture barrier, a horizontal isolation layer in the walls against the rising dampness. And we shall have new fundaments under all wall of the house in the middle, with insulation against dampness from. And you remember, this house stands just nearby the river. So it looks like it's another place. That's also Bamberg, at about 200 meters from this house. And I think you know this phenomenon. All is wet in the local region, and most people say it's rising dampness. Do you know this phenomenon? Rising dampness? Is it well known?
Nothing to know.
Huh? Should be. Does rising dampness exist? Can dampness rise? Do you think dampness can rise in a masonry? Who believes that dampness can rise? Please, hands up. 1, 2, 3. So, makes it sense to have a horizontal insulation against dampness in a masonry? Makes it sense? So I say there is no rising dampness. And here we have the town hall of Bamberg. It stands in the river. And that's the other side I showed just here. That's this part. You can show here. You can see here. And perhaps you know the borehole injection is a measure against rising dampness. Others tell you you can cut the wall and give in plates and things like this. I say there is no rising dampness in a masonry. That's from Leipzig Denkmalmesse. The businessmen selling such things, they show columns from masonry sitting in the water, and after 1 week and also after 1 day, they cannot prove rising dampness. So they had to descript it here. Rising dampness. It's written on a plexiglass, on an acrylic plate here. And what happens is the first layer of masonry will be wet, because by capillarity it takes the water in it. But then comes the mortar, and the mortar has much bigger pores. The porosity of the mortar is much more bigger than the porosity of the stone, and so it is no chance at all for a capillarity effect, because bigger pores will never suck any water from fewer pores. And this you must know. But the industry will say just the opposite, and will make a big hoax of this, and will sell special rendering and special measurements against rising dampness, which even does not exist. This is a special rendering they have for a very high price. It's about 2,000 euro cubic meter for this material, and it's only a porosing chemical in the cement mortar. It's nothing more. The worth in material is about 50 euro for cubic meter, but they can sell it because the promotional work makes the people believe in rising dampness. So in reality we have salt in the masonry, and the salt will kill the render and will kill the bricks. And all what you must do is only bring out the salt. So wash it out. The salt is soluble in pure water. So wash it out. And then you can take pure lime water and all is perfect. Not following the industry. That's a principle for better work. Then, when we understand the building, we must have a closer look what is under the first layer. And here is an example from Poland. The Polish people are very well known for good restoration work. Some years ago I got an invitation to Poland to have a closer look to Polish restoration work, and then I found in Torun, which is now named Torun, Copernicus comes from there. I found this example for conservational research, and I think the restorator must have been paid by square meter, not for the analysis, not for what he found. He was paid, I think, how many square meters he must destroy. And so he makes damage at the whole house for 100,000 marks in the time, only to repair the conservational work. So we prefer to have very little insights, very little research points, and just made at the exact place. And then we get the complete insight about the history of the building. So the trick is to have a good conservator, to have a good restorator, which is clever and don't need huge holes to destroy the building and get out something that there is a late Gothic structure, well, because he will find more. There is a late Gothic structure in this classicistic facade. That's the whole thing. And it was enough if he had looked here. So we need very clever restorators to find it. And in the end, what to do with all these holes? In this house we had about 3 or 4 such research, and get the whole information, 10 layers onto the medieval time with very nice paintings in fresco and so. In the end, we can make a Piet Mondrian out of it. So we save money also for the interior. We have it only by research. That's only a frame and the glass. And you see the electricity, we must not dig in the historic structure and destroy all the historic render and all the historic places and materials. We can only give on the top the electricity, like we can see here. Very clever done. Chinese are very clever conservators, I see. The big work is to understand the building. And so we make a geometrical survey to get a plan of the building. But the survey must be very exact. It must follow all deformations. That's the principle. To understand the whole building correctly. That's a Renaissance building and another place. We have all deformations which the building has during the times we have in the plan of the existing building. And so we can do very exact planning of every cable, of every tube, of everything through the building. And besides, we have the historical phases. It's not a big thing to get them out by some very small holes. It's not much money for this. You need only the clever restorator who does this in the end. And in former times, when we started this, we do all by hand, all by hand. We have not technique. We had ropes through the rope axis, through the rooms, and then we do every measurement only by hand, and we make the complete design just on the place. And we go at home with a completed paper, with a building on it. This is a clever method to detect where are the problems of a building with several stores. We show in blue colors, more or less blue, how much weight comes on the walls. And in yellow to red colors we show where the weight is coming but has a wall, has not a wall or a column on it. And so we can detect the problematic parts in the static of the building, in the construction. And so we can react exactly and must not throw a lot of steel through the building and damaging the most parts of it only because the civil engineer has no idea. It's a very easy to do work. We have only the layers and then we can detect the problematic parts. So in Bamberg, this was a deformation-proof research. And we can find out we had a historic structure. This had been renewed in Baroque times, this facade. Here we have the late Gothic framework facade. And in the Baroque, they just put the walls from here to here. But in the upper floor, this wall remains here. And so the crack of the main beam comes. And so in the renovation, only column solves the whole problem. And this column, the client bought in the next market and managed to have a plate of metal. He works in Bosch and he brings from the work this little plate, does it under the broken beam, put in the beam, and all was good. The next problem, how to catalog all what you are finding in the building, all materials, all constructions. I sent my employees to the building and with white sheets of paper, and they go there and make a catalog what is not okay with the building. And then after one day, all the 5 persons come back with plain sheet of paper. What have you done? Have you only smoked? And no, they said, no. To say it frankly, we did not know what is the name from this and this and this. We did not know. We have never learned what is the name of these parts in this old building. And if we know the name, we don't know, is it damaged 10%, 12%, 13.5% or 70%? And in the end, we did not know what to do with this. I said, huh? You architects? No, we did not know. We did not know. And so I decided to solve this problem. And how to solve it? I show you the original solution from this Bamberg project from 1984. And this is some years later. And this also. And I will show you the newest version. It's written in German. I will give you the details in English so good as I can. The main problem is the people don't know what is the name of the construction. So first you must have a multiple choice system with all the names of all the construction. And it's multiple choice, and in this case, in the first beginning, I did it by rapidograph. We have not computer. And so we have here the main structures like wall and rendering and stones and so on. And here we have a multiple choice system, what you can find normally in a building from Roman time to nowadays. So he can underline what it is given in the building. That was the first thing. So they cannot say, I don't know the name. They can learn it. The next is, what is the damage? And then I found out, this is here, there are only very few damages. Maybe it's rotten, maybe it's broken, maybe something. Here we have about 18 different damages. And he can give the number of the damage here. That's a new form, it is on Excel now. The next question is, how many of the construction is damaged? So the volume of the damage, it comes here. And then comes what to do. And then I found out there is very few work to do. Perhaps it can stay because it's not a problem, or you will have a little correction in it, or you will have renew the surface, or. So we have about 29 different things you can do at a damaged construction. So again, some numbers from the catalog given in here, and then in the second niveau you have a graphic documentation, the walls A, B, C, D, E, F, G, and the floor and the ceiling. And you will portray the damage. So you have a correction. If there is a wrong number, you can find it here again. And in the third niveau, we have photographs of this. And so we can pack in the whole building in some sheets of paper in absolutely detail, in absolutely correctness, and everyone will bring back the same result. Because it's no chance to make it very bad. All is given. That's an actual work from Berlin Orangerie in Pankow. And you see the portraying the walls. This system comes from 1984. And it's good. And the catalog system we have updated. This is a catalog. And very few damages and very few measurements. And this is a result of a room, the building part, the constructional part, the damage and the measurement we have to do on the part. That is the whole thing. And look a little closer. For example, here we have a construction. It's the title. The building part is the supertitle. Here we have the number. And here we can decide it's from the inner or the outer part of the facade. So we have number 1 or 2, and then we have to decide, is it, for example, masonry, and then made by stone, the next hierarchic niveau, and then maybe a stone from the field, a stone from granite, a stone from basalt, tuffo, sandstone, brick, and so on. So it's a very clear hierarchic system where every part of the building comes in a hierarchy. And it's given. And if we found a new stone made from shit, for example, it can get his number. So it's in the system. And so it is with all parts of the building, they have a hierarchic number. And so we can control it, and so we can learn him, we can find him out. And he is in the paper, because in the end all must be in the paper or in the computer. Because my projects are not in front of my door. It's in Hamburg, it's near the Alps, it can be everywhere. And I go there for some days, for some weeks, and come back with the whole thing in my documents. And here we have the damage. Number one, no damage. Number two, a constructive damage. For example, belonging the static, the binding, the deformation, or it is missing. That are the four constructive damages. There are not more. Then there is a functional damage. For example, now it's a sleeping room, or had been 300 years ago a sleeping room, and tomorrow it shall be the kitchen. It's functional damage. The point of view is the new usage. And then we have also maybe aesthetic damage. Maybe the wife of my client says, I don't like it, it looks not so nice. And then it's an aesthetic damage, and I must have number 4 and must paint it yellow, for example, or in golden, or make some arcs in it so the wife will love it, and so. And maybe there are some parts from outside. So the birds have given parts on the facade, or. So that's point 5, and then point 6, it is missing complete. What are the possible damages of a construction? From no to missing. And here are the measurements. It's normal, no damage, no measure, no work. Second, take it away. Third, throw it away. 4, store it for a moment to get it in later again. 5, correct it. 6, build it in for new, renovate it. 7, renew it. And then here's a hierarchy, renewing like the existing, modernizing, so make it better, or historizing. That is the system to get the whole planning of the renovation in the paper, in the document. That's one of the main things I use to be always in the budget. Because with this system, no work will go outside, will come from itself. Some questions?
What's the meaning of number 3 in
historizing? Historizing. We have a plastic window in the main facade of the Baroque building. And the former owner or the former tenant said, oh, I do a new window, the old is gone, and he gives a plastic. And then I come and say, oh, a wonderful plastic window, it works functional, it works constructive, but then comes the office of renovation, say, oh no, not plastic windows in our Baroque facade. And then we must renew it, historizing, and must make a new wooden window in historic style. And I try not to historize, but the office of restoration is not every time my best friend. Okay? And I say, if they give the money, they have the right to say and to historize. But if my client must give the money, I say, oh, look what a wonderful plastic window. You understand me? Yeah. That's my point of view. In magazines we find it's often not enough only to look at the surface. What is the situation of the building? Very often you must do so to detect the problems of the framework building. And that's an actual example in the former GDR and that's in the capitalistic West. And so you can see they have too much money. And also in the GDR, it was done in GDR time, in the communistic time. They have also too many money. I don't understand. My clients never did so. And why did they do so? Because the experts say, oh, let's give every worm in the wood 2 names, a Latin one and a German one. And I say, I'm not interested. I like worms. And maybe they shall not be so much. So I have to dry the wood. I must repair the roof, and then they will go from itself. They are human beings. Let us be Buddhist in restoration. Not kill all. And not kill the clients. In wood construction, we do so. That is our catalog system. So every main part of the roof, of the framework, has a name and has an abbreviation, 1, 2, or 3 characters. And then I found out we have only 9 different damages which are possible at a wooden part of the building. And then I make it in a graphic way and I show, for example, this is rotten. And then we have 2 possibilities to repair it, so or so. It gives a number. And then we can decide about a catalog number in the planning what to do with the wooden part. So, for example, we have a rotten part from the beams of the roof, and then we have to renew these beams in this way or in this way. And then we can decide. Here I repair a castle, the roof of a part of a whole castle. So every system has its number, and the system and the parts have also their names given by numbers. And so it looks like how to do with a wooden construction. We name it list for the wood, for the survey. Here we have part of a facade, of a framework, and then here comes the numbers. First, which parts, which damages, and here, which measurements. Very exact, very clear, and working onto the end of the whole work, and no surprise. Another wooden house with a lot of damage, you see, but we make it also very clear, wall for wall, what is rotten, what is okay. So we must do planning very exactly onto the last nail. Then we have a chance to make it in an economic way. Here's a whole little wooden building. All parts are documented. And then we have the possibility, the opportunity to repair a building, and it looks like it looks maybe never before or 300 years ago. And you must imagine, if you have a private owner for such a building, it needs a lot of convincing. And if he sees all the paper we do, he is freely willing to pay the money. If in the end he understands it will work, the whole planning. And so here we manage what to do with these inner parts between the framework wood. So we have a catalog for every part of the building, and in the end, first we stabilized the whole facade, then we lifted the complete house 50 centimeters, repaired the beams at the socle, and then it come down again. Then the inner surface we coat with a reed, then comes new rendering. No discussion for patina, but we go on the rotten render and don't throw away all what is damaged. No, it remains in the building. It's quite good and it's original, and maybe some mice are in it. It are the mice of the client. I will not kill them. And here you see my client sitting with his guests. Now it's a guest house. And my client has the right to decide which interior he wants. And that's a hard thing for an architect. But we must be humble. We are back at the Bamberg house. Here's a broken part of the main beams. Before and after. Also here we layered, we rendered new on reed. And here is a 150 marks beam, the pillar, done in do-it-yourself from the client. And this little thing manages the whole static, and we don't have a civil engineer. What will he make? You can't imagine. And it will be hundreds of thousands of marks in the former time. And all what you can see here is under the layer of the fresh lime mortar. And this we must change, because this is now the main door for coming in this apartment. And we had this door from another part of this building, and it has only 75 centimeters and 180 the height. And it's not standard. It's not building standard. And all normal people will say, oh, it's forbidden to do so. And I say, no, you must not have the very thick tenons in it. So it works, and they love it. The neighbors, as we started this project, they said, throw it away, it's not worth anything. And when they see there is a building place, they come every day from the neighborhood and said, you will never find a tenant going in. But in the end, they had 20 applications for every apartment and can take the one with the most cute nose. Next example. It's a Baroque monastery, and I saw some cracks in the facade and don't understand where the cracks come from. And I argued the roof. And then I found out the former architect did completely renew all tiles, and did nothing at the wood. And as we opened this part at the foot of the roof, we can shovel out the whole wood because it's rotten, a dry rot. And this is what the former architect does. Some new beams, some new lashes for the beams, only the outer part to get his new tiles on it. And the whole work maybe was done from the industry for him, because a lot of us decide not to do the work by themselves. If they get no money, they will not work. So how to manage a restoration work? What shall they do? In former times they had a telephone, today they have a mobile. And in this mobile they have 20 numbers that are the 20 firms which are helping them willingly. And they say, oh, hey Joe, I have a new project with a big facade. Will you do planning for me? And Joe is from the firm who produces render, dry mortar. And he says, oh, I'm coming next hour. Do you have time? And he comes and he makes the whole project and gives for no money to the architect. And it's a big work. And the only intention of Joe is to sell a lot of dry mortar. And he is not interested in the historic mortar and in the repair. He gets his money for selling every quarter a lot of dry mortar. And so he does the work. And in the end, if the new dry mortar comes here, on Christmas Day comes the reindeer sleigh. But not one reindeer. They need 6 reindeers to bring the gifts for. And in this way, he can do the work for no money. And his spite has a golden block and goes to golf. But I cannot do. Back to the roof, we found a lot of rotten things. You can imagine maybe here. The whole situation was rotten. Why? Because the timber work was done first to get the tiles on it and to can, in Baroque times, build under the roof in a dry situation. And then comes the masonry, and they do here a counterweight to get rid with the
overhanging cornice.
This part of the facade. And that was a given situation. And that's a repair, some new wood, and a new counterweight which will not anymore inbind in the wooden construction. We did not reconstruct this point, we make it better for the future. And now the new wood is in a surrounding of air, and no condense will go into this part and will be stored in the masonry around the wood. That's a technological improvement, and we did hold the work under a scaffold roof. So only this part we changed. We take away the tiles, we open the construction. Here we have a roof which is coming on the scaffold. And this is the result of our wood list. Here we have the whole ground plan of the roof construction. And every system has a little code with all the numbers of the catalogue. So this gets the craftsman, and he knows what to do at every point, only by the numbers. And he has a list where he can find what the numbers mean. This works. It's about 500 points, and the first point, we proved the timberman to make it. And the first time he didn't understand how detailed we mean what is written in the planning. So he must take out 3 times his work, and from the first time it was perfect, and it goes perfect the next 500 times, and we did not even have any discussion with this man and his friends, his craftsmen. It worked very fine. Some inside the situation before the work, and here we have new beams And this is a ready-made repair work. It looks like sugar, perfect. This is a little roof we have on the scaffold. And the tiles we stored on the scaffold, and in the end, all the tiles come back. And the costs had been only the third part of the normal costs of all my colleagues at such a point. We looked for the meter, and the meter costs had been about 300 marks, what is now nearly 300 euro. The whole work at a meter of this roof. I think it's very important to save all what you can find on your old building. And for example, here we have Baroque, so about 300-year-old tiles, and they are damaged in a certain amount, but all which had been good, we have a hammer, a little hammer, and we hammered on every tile to hear, is it good or is it not good? And all sound material, all material which gives a good sound comes back. And so we sample it on the best side of the roof where the public will see it. And here we must have new material because we have not enough good old material. And that's the same castle, Neuenburg. And here you can say what the craftsmen are doing. And they will make, in this case, a little puzzle. And here they got tired and they will make the whole thing so. But it's not a problem because only from aircraft you will see this not so aesthetic solution by recovering all the materials. That is this castle, and you can imagine it makes sense if the architect has the civil engineers under his direction and can find out how to manage such a thing on a narrow mountain. And I show it, here is a repair work, what is thrown away from here, what comes down the mountain. And here also we have all historic tiles again on the roof. And these stones come from here. The town hall of Bremen, it's a UNESCO monument now. It's a new one, but it's also 100 years old. And if someone had been in Munich, maybe he or she has visited the Munich beer hall Hofbräuhaus. And the architect of the Hofbräuhaus, his last work was this town hall in Bremen. He comes from Munich, and they took the repair architect also from Bavaria. So I am in a tradition. I did the outside repair of the roof and of the facade. And here I show how we manage the roof plates by copper. All are recovered, all are reused, but when we took them from the roof at their edge, they are broken because of the binding, the historic. And so we cut 2-3 centimeters from the edge away and make a new binding, and from outside you will not detect the difference. And so we can manage to reuse all historic and all patina sheets of copper. And we have the historic repair parts also in it. And this saves a lot of money. That's from a friend of Bruno Siegelin, a late Gothic tower with colored tiles. And here the historic construction comes down because of the cement mortar. The cement mortar damages
the rain tightness
of the roof, and we repair with poor lime mortar. And it works. If you know how lime mortar works, it will stand the frost and the rain. A very common problem is to fix a corroded surface of the material at the facade. And this is the way the industry gives us. It is industrial made fixing material. It's siliconates, it's silicates, and acrylic substance, and it doesn't work. I can say about research about many years, it does not work. And they promise all, but it's a lie. It's a hoax. It does not work because it doesn't fit to the material. All the synthetic solutions in the surface, they will make it too hard and too dense, and in the end the whole crust must come down, like we see here. So how to do? How to repair a rotten surface? Only by lime wash and by historic, traditional, proved materials, not synthetic materials. And so we did the whole facade of this town hall. Here you have an image from the restaurator. I came to the building office of the town hall. The first time I get a phone, will you make the repair of our facade of the town hall of Bremen? And I come there to have the first discussion. And they asked me, Mr. Fischer, how will you repair our facade? And I answered, I don't know. I never had been in Bremen. I had never seen this house, but give me 100,000, then I will say it to you in 6 weeks. And they gave me the money because I can explain. We will have an axe with a scaffold where the most important damages are, and we will only try out. We will have a pattern for work, and then we can look what is the reason for all the cracks, for all the damages, and then we can try out experimental how to do the repair. And in 6 weeks, the restorator and me will find out the whole work. And so we did with our catalog system, and the restorator was forced to write exactly how much lime, how much water, how much this, how much this. And with this we can calculate the complete work only from this little part what we do here over 6 weeks. And so every stone gets his number. You can see by chalk. We go there and we decided every part. For example, here we decide to have a little layer of color, of paint. And for example, here not. So to discuss a patina problem, we said, if we are standing in front of the facade, what will hinder to understand the architecture, like big white parts in the colored facade? We will have a retouche. And the other parts, which are only little damage, we remain. We can save the money. And so, part for part, the whole facade, we had the documentation, but it is very quick. We are running over the scaffold and say, oh, this number, this number, this number. And in few days, it was managed. And after 6 weeks of work, of analysis, of trying out, we know how to do. It was from November to December. And after the winter time in spring, we go there with a
elevating platform.
And we look how the repairs work. And we detected about 5 to 10% which did not work, which didn't meet our expectations. And so, to this 5 or 10% of work, we can decide to have an alternative. And so in the end, all works very well, and we saved about 40% from the budget in the first phase. It had been divided in several parts, the whole building project, and every facade we started from new with this work, with the trying out, with the experiments, because every part of the facade has its own problems. That is again the monastery. And here we see a wonderful facade, just 10 years old, made by the industry. Okay, it was a restorator, but the material was from the industry. And the planning was also from the industry. And the industry in Germany has managed to seduce also the conservational personnel in the governmental offices. And so the industry can force the personnel of the governmental office of restoration to write in the expertise, you must take the material from this firm. I will not say the name of the firm, but it's pure silicate. And maybe you know this very good silicate painting. It's
Sports.
I say. Because after 10 years, all is rotten. All is rotten. It's too dense, it's too hard. And so it looks after 10 years. That's the modern times, and the
seduction
of these persons go to the architects and go to the government and go to the conservations and to the restorators, only to sell a lot of
thoughts
to the old buildings. Here we see our catalog system on the facade. We changed it 90 degrees. It's always the same. Here we have an update of this catalog. So only what the given construction is written in, and here's the damage, and here's the measurements. And you can see this is a modern art of painting by silicates. What do we do? This is the underground. It's a Baroque mortar, the underlayer. The upper part has gone by silicates, and here we renew what isn't here by poor lime mortar. 3 parts sand, 1 part lime, calcium hydrate. And then a lime wash, and in the end all looks like 300 years ago. And costs much less money than a modern industrial coating. It is cheap and you can buy it everywhere, but the craftsmen will not trust in it because they haven't anymore the know-how to manage the binding of the lime, and it will chalk down, it will be like sand or like chalk or like rain, and the art of the craftsman is to manage the binding of the lime. That the reaction of carbonization works. That's the thing. That's the only secret. But few craftsmen do know this. Coming to the materials. Here we have the thermal expansion of construction material, what is a very important thing. We can see the bricks have a very low thermal extension. It's 0.4 millimeter per meter per 100 Kelvin. And for example, concrete has 1.2. And so you can understand why concrete buildings must crack down by thermal expansion. And the rendering, here we have lime mortar, it has 0.47 to 0.48. It's exactly the same in principle as a brick. We have natural stone, 0.8. And we have synthetic resin plaster, 1.2. And we have cement mortar, 1.2. And we have other mortars, 1.8. And gypsum mortar, 1.8 to 2.5. That is big dimension for the facade. And insulation material like polystyrene, expanded polystyrene foam, it has a thermal expansion of 8. It will never work at the facade, never. Here the same, we have the stones, here is the armed concrete with steel in it. Here we have the mortars, here is the lime mortar, 0.4, to lime gypsum and gypsum mortar, 2.4 or 2.5. And here we have the cementose mortar 1.1 or 2. That is big dimension for the facade. And that's important to know. In the result, this is a cement mortar after 10 years in Italy, in the city of Rimini. And I found this. And this is a 400 years old lime mortar facade of the Gothic church in Rimini. It doesn't look so aesthetic, but it has no crack and it works. Here we are at the railway station in Malmö, in Sweden. And you can see they had a repair of the joints, and they repaired with cementose joint mortar. And it's crazy because it destroys the whole building, also the stones, because the water will not come out. And because of the thermal expansion, there will be the cracks. And in the cracks, the material is sucking in the water. And then the water remains and destroys the construction behind the mortar. And in the end, the mortar must go away. And he says, I'm not responsible. Here the
practical moisture
of material in normal condition. And we can see brick 1.5 volume percent and concrete 5 volume percent and aerated foam concrete 3.5 volume percent. It's much, it's damp. Here is also an interesting question. How many times will it need to get out the water of material? A French building physics expert has tested it. Lime mortar needs, it's a figure 0.25, but cement mortar needs 10 times more, 2.5. And the example here is a formula. T is SE
squared.
and the formula says T is day, S is a value of cardiac, it's a French name, and English characters D is ST
Squared.
and T is a thickness of the wall. And so a brick wall 50 centimeter filled with water will need 700 days to be dry. 700. What means a concrete or a cementose wall will need 7,000 days to be dry. And this is also important for all the structures of concrete you have in the floor, you have in the ceiling. They need a huge time to dry out. Here is a behavior of brick and lime sandstone. And it's a shrinking of the lime sandstone and nearly no swelling of the brick. And they must heat up to 600 degrees. Nearly no swelling, but a huge shrinking what isn't finished after 180 days. That is modern material. This is traditional material. And I can say, by technical purpose, we must stay on the traditional material. It's not, I love it. No, I love good techniques. I love good material. And modern coating on historic facades. Modern binding by resins, that's Italy. This is the facade of the late Renaissance and late Gothic facade of Bremen after repair. And you can see no difference to the situation before. No difference. But all holes are filled and all materials which come out over the times we repaired. And the cement joint mortars, which had been stable between the joints, it remained also. We did not cut out. Only where it comes out from itself or where it's lost over the time, only this part we repaired. So we did not an idealistic project here in the facade repair. We did only where the needs are given. And we have not an ideology to have it like so or so or so. Never the centuries ago, besides the last 40 years, this facade looked so. Because we know exactly what was the shape in the late Gothic. We know exactly what was the shape of this facade in the Renaissance when they changed all the architectural decoration. And we know exactly how it looks like the 1920s or 1860s. But we will come back to the last generation of repair. That's the thing. And that costs nearly no money. It costs enough, but much less money than normal. Berlin. Here is the TV tower. Here again we have this very famous silicate painting, silicate coating. It's 100 years old. And if we hear to the firms which produce this silicate, they say, oh, we have very good experience. Over 100 years our silicate coating is working. So it's working or is damaged. And this is cementose mortar done in the 80s when they had repairs at the facade of this tower, and they had not the money to make the Baroque rendering the whole tower. So they decided to have joint mortars in a very crazy shape, and water comes in and takes out a lot of crusts and residues and things like this, and we managed to repair this. We will not throw away the cementose mortar. Again, we could manage to have the repair only on the certain points where it is a need, and the rest we have open holes in the situation between the stone and the mortar. And we filled only a little joint which comes with lime mortar because it can do this work very easily with very few work. And so the whole thing gets with very few work a new function in technical sense. How to do this by catalog. Every part of the building is catalogized, and then the system comes. What is in the construction? What is the damage? And we have to decide whether a thing is only not nice or it's a problem for the future of the facade. This is also a decision we have to make. Here we have documented all damages. And then comes the decision, is this damage tolerable can we say you are the beloved partner, or is it a problem? And if it's a problem, we have a measure against it. The measures to do something away, to have a free room, a free place to make new work, or it will something come to the construction. And then we have the test field, this lime wash, and in the end, this is PIX 2006, and this is very actual PIX. We have nearly no damage from this lime wash, midst in Berlin, and everyone can go there. It's a very famous place, Alexanderplatz, Alexander Place in the nearby, and the TV tower, you can look there, also by Google. It's not damaged. It stands here since 2004 in poor lime wash. Sometimes the window is the only thing what holds together the house. And now some words about window. The modern window doesn't fit the needs of the tenants. And so they have little film to make it more cute. The other tenants say, it's okay for me. I'm a modern tenant. But here I think the wife has better idea. Then comes the architect and say, oh, we will put down the whole building and we can reconstruct much more cute, much more nice than it was before. So the complete house is a reconstruction, and it's an identical copy of what was formerly there. And also the window, it's very nice, very nice. The only problem, there is nearly no more light in the room, because all is modern construction and all building regulations are fulfilled. This I show very voluntarily my German friends in the lectures, and I say, that is window. We find these windows in France. In France, there are not so much crazy architects as in Germany, I think. Or they have not so much money. Because there are little places where I found German windows also. But that's the original, and I think that's nice. And that costs not much money. That is a German solution. Very technical perfection and very aesthetic and functional, and that's quite good. And all my clients want such windows, all my clients, because they are afraid there may be some winter, and they didn't believe in global warming, I think. And they say we must have the perfect insulating window, and this is the solution the German high-tech industry will bring to the facade. In the end, the window cannot let the water out, the air humidity. In the end, all is molded. We have black mold overall. The whole Germany is filled up with black mold, and this is not the owner. But the owner does want such windows, but he cannot manage it. And to say it frankly, it is impossible to manage the air humidity with absolutely hermetically dense windows. It is not possible. The only solution is to get out the air humidity suddenly. And so all historic buildings get new windows, then all historic buildings have the mold, and after this all the historic building has that tenants, or they must buy a ventilation system. So that brings a lot of money to the firms. Then comes the ventilation, and if you have a closer look into the insulation and give it in an agar-agar, you will see the black mold has not diminished. It's more, and now it's in the ventilation. And okay, you can filter what is coming in, but you cannot filter what's going out. And so a lot of sick people are living in Germany by the anxiousness of the next winter. Did we need two double glass windows? Do we need it? I say no. Why? This diagram shows the permeability of sheets of window glass against the different radiation. That's UV radiation. It will not go through normal windows. Here is a light. It will pass the glass. And here is infrared. And the most important part of warm infrared will not pass the window glass. We know fire protection doors and fire protection glass, you can see the fire, but you will not burn, because the infrared radiation will not pass normal glass. So it makes no sense to have double glass, double sheets. What is behind this window? Which function may be behind this window? What do you think normally? What is a function behind such a window? What do you think? No answer? A toilet. That is a German answer. And that is the window of the toilet of the house of my mother-in-law. And you are correct. Here a toilet is behind the window. But in this case, it's a sleeping room. And the building regulations will not have such windows in a normal sleeping room. It must be about 10% of the square. But who want that all neighbors will look in? Most important is that the air come out, and this works with this window. And who will read whole the night with moonlight? We have electricity in Germany. So why not have such window in a room? And you can imagine that saves a lot of money. Back to Bamberg, the situation before and the repair. And every part you see here, it is here also. It's an old window, it's old parts of the lintel, it's a little bit lime mortar here. It's good. The old window before and after. We had an inner window because the people are so anxious that the winter is too hard. Okay, I will commit, it's a better sound protection. How to repair such historic window with a big history of repair? What to do? We must decide to repair each single window for its own theory to save money. And it's possible to repair such windows, and it's cheaper than a new one. I tested it out in thousands of cases. It is always cheaper, and nobody knows. The modern coating of windows is made by industry, by synthetic material. And after one winter and one summer, oh, it looks like it is not able to stand the weather and the sun and the temperature tension. It's too hard. The castle of Merseburg, we have 750 windows in 150 different constructions. I know it exactly because we had done the catalog system. It's a Raumbuch, room book. And that is the situation before. What to do? Every window get his numbers on a sheet of paper, glued on the glass, and then we repair the wooden parts, part for part, after the catalog, and then we give linseed coating on it. And we think it's the best. It's a nature material. That is a building for justice. Our catalog system, as it is done with windows. Here we have the images, the measurements, and here is the code of the catalog. Here we test out every point. Here 1, 2, 3, 4, 5, 6, 7, 8. The 8 angles of the window. We test how much wind will come through the window. And if it's okay, we can decide it can remain. And if it's too much air which comes, we have a repair. Very easy system to find out what is going on in the window. And then the work, okay, linseed. Back to Merseburg, that's the end of the game. The draft. How to draft in historic buildings. And my theory is nearly no change. Drafting to make new function in an old building by safeguarding the money and respecting the building is you must have mostly the complete construction, 95% I say, and then give in some new parts. For example, this part is a new bathroom. It comes additional in the construction, but we have only here and maybe here a changing of the structure. Or we found here or here, we gave in the apartment at the first floor, and the rest, all the structure remains. We try to understand the drafting in an old building like a puzzle. And if you are puzzling all the parts, you are not allowed to take a scissor to take away what not works in the first moment. So we think we must play a functional puzzle to get our new functions in an acceptable way into the old building. That's all. I will not say any more to this. And I know if we look to certain building projects, this is not possible because modern needs make it not possible. I understand this. But in our case, where the same function, a residential function, comes in, we can do so. And that's the end done in poor lime wash. And all the old particles of the rendering through the ages are under the new layer. No patina, but the whole thing is in it. And we spend very few money. Making again from the ruin. That's the end, what the media will tell about the game. That are my clients. The next, and I think the main thing, after the catalog system, is how to control that our measurements will come to the practice, come in reality. It's an informational problem, because we have a very good thinking, a very good work done in our paper, in our documents. All problems are solved in the system, in the code. But how will this planning come in the building? It must go through the head of a craftsman who is a hand worker, not a head worker. And how will we convince his hand to make what we have planned? That is a main problem we have as architects, because we are intellectuals, we are good on paper, but in the end there is a craftsman. How manage this? And I found out the main problem is the information, is the communication. And so we must regulate this problem. And I found out how. I will show you. Every work can be described in 12 text positions, I say to them. It's a position-based working instructions for the offering according. We must describe the whole work and then we get offers from the firms. That's a normal situation. I think also in China, I suppose. You have a planning and the firms will offer how much money will they get for the work. And if we can say exactly what we want, they can exactly say what it's worth, what is the price. And this process needs information. It's a system based on positions for working instruction, and we must give it to the firms during getting their price. It is an offering according to procurement procedure for building works. What is the problem? We must say to the firms exactly what we want. So we must do our whole planning codes and our lines on the papers. We must give in words to the firms and they must give us the work and get the money. And in this process, all depends on the architect's ability to make a fair description of all things. Because if we have forgotten something, the firms are very happy, because in the mid of the building process, they say, oh, no, what doing now? No paper, no offer, no price. And then the costs explode, because now they can do the price and there is not a concurrence. The challenge is to describe the work exactly, that they cannot go out of the treaty. And all is written, what must be done, onto the last nail. We need 12 text modules to make the description. First, that's logical and number. In the end, the total price for the work. That is easy. But in the middle, we have an abbreviation of the whole thing, because we must
Go over the building site
and must find in our documents what must be done here and there and so. So we have abbreviation. The second is the abbreviation. Here we see the 12 module. First is the number, second is the abbreviation. Short version of the position is a position to the modules. Then point 3, the price influencing situation of the building
site.
He must know what influence is given to my work from outside. And so we had to describe the building site. Are there problems? Are there dangers? Are there risks? Just around the work we will have. And then what is important, is there a hazardous situation in the work practice? Then the effective processing area of the building. We must describe the place where the work is to do. The building part, the building construction must be described so that he knows which is the damage, which is a given problem. So first the situation, then the detailed building part. It's also in the number 3. Then comes 4. We must say to him what is the result of your work? The constructive, functional or design performing result of the whole thing. So we give him an aim, what is the finish? What is the final solution for the whole work? And then comes the description of the whole work, what he has to do, what he has to deliver, which materials, and we say him much more details belonging this work. In the end, he gets a reference to the designs, to the drafts, and the unit price and the total price. It is our responsibility to describe the work so that every firm can understand it and make a fair price. And if you manage this in a good way, you will meet the budget. So much to this problem. Now, some case. That's Berlin, the orangery. That's my actual project. That's the wife of King Frederick of Prussia. Under her age was this built. It's a ruin, a completely ruin done by GDR. And that's the situation before. We found that shall be the end. We are not in this situation now. We are in this situation. The draft 3 residential buildings and park from the historic orangery from Castle Schönhausen. And there are new buildings which bring the financiation for the repair. Then first safeguarding, done 10 years ago, 10, 15 years ago, safeguarding. I did also this project. This is a situation now. We had the first proofs of repair of the windows. We have the first proof for repair of the facade with poor lime wash. And we have the first proof for the inside to show the clients what they will get if they will buy the apartments. That's the situation today. And then I come to the finish. Angst, you know German Angst, anxiousness, anxiousness, anxiousness. We are afraid that our cathedral in Cologne will be in the water in the end, and the whole globe, the whole world will burn in global warming. And global warming will show us the way to modern buildings. And we have our female minister for building, and that are her best friends, that's the bosses of the industry, of insulation material, of new heatings, of new plastic windows. And they say we need a change for the building. This is the future of all old buildings, and no more old heatings. All must be done because of global warming. And they say that's not the only reason. Also the fossil energies will
be finished.
In some years, no more fossil energy. So I ask you, is there fossil energy? What do you think? Is there fossil energy today? All believe there is some fossil energy, isn't it? And I say it's not at all any fossil energy. It doesn't exist. We have oil, we have coal, we have gas, but it's not fossil. Who says it should be fossil? 2 crazy persons, I can say the name. Georgius Agricola, 1556. He says it's from bones of saurians and so, but his books were filled up about stories of the dragons in the mines and of little dwarfs, very mysterious people beneath the earth. And he says it's fossil. The next is a complete crazy Russian expert, a scientist, Michael Lomonosov. The Moscow University has his name. And he, 757, he saw some rests of trees in carbon coal. And he says, oh, it must be from trees. And these are the both inventors of fossil energy. But Humboldt goes to South America, 1800, and he saw the lakes of raw oil. And he says, no, it's not. It's a crazy theory. And since the 50s, the Russians found out it's not fossil. And they go under the mantle of basalt and granite and the
primary rock.
And they find there, where never fossils had been, tons of gas and oil. So there is no ending of fossil energy. It's huge onto the rest of the world. That you can prove in the internet. And is there any global warming? The Englishman, that's from Hadley, the meteorological station. Nearly every day we see this diagram. You know this curve. It is a global warming, but in Bavaria we have a station we are measuring for ourselves. And this is 1781. And look, That is 1800, in the midst of the 18th, and that is the point the Englishmen are hoaxing us. And here we have actual dates, it's CO2, and it's the temperature, and it's diverse. And now we have a chief weather
prophet of doom.
and he says, the next 10 years it will come so, and it's all hoax. Because CO2 cannot manage anything to temperature, besides of cooling. Because CO2 is much more a cooling gas, not a warming gas. So much for this. You can look to the internet, you will find it. It's climate change deniers. Have you heard of this? I'm one of them. That is a reality in Germany. Falling temperature. And they say such things. How many CO2 is in the air? That is the CO2 in the amount of air. That is O2. The black one is nitrates and so on. We have nearly no CO2 in the air. And this shall manage global warming? They are crazy. And they say we have more and more storms and much water in the rivers. And this is 70 under 84. That's in Heidelberg, 70, 84. 1595. And this is 1970. What did they do in these old ages? How many cars did they drive? And our government makes programs against CO2. They are completely crazy and give all our money in programs against CO2 and destroy our whole society by following the global warming hoax. And our whole Germany now looks like so. And we close our energy plants to get this baroque method to get some energy out of the wind, which never is enough. And then we buy from China the solar panels, very cheap, on every roof you have solar panels. And here in GDR, solar panels, now they have invented the solar sheep, and they buy sheep to bite out the grass on the solar fields. It's reality, and they sell the solar sheep for food, and they promote it. And that's in Hochstadt am Main, where my office is, 2005, I think. All the panels will destroy very quickly because of sun, and the electricity will damage itself, and all the buildings will burn down. And I have a chronological archive in my website, and nearly every day new complete burnings come to the chronology. So that is what our German government is doing with global warming, and they enforce all people to follow this way, and this will be the end. All the wind machines and all the global warming Chinese panels, and that's the German of the next generation. That may be me. Yeah? And that is our sign for looking for work, because more and more industry must close by this politics. And then comes experts and say, oh, your building is not good, it is not insulated with polystyrene foam. And they show this, and say, oh, very good insulated, and very bad. It's a historic facade. They say, it's very bad. And then they come and say, look, here it's insulated, very blue, and this tenant hasn't done the work, is crazy. And how shall they describe that the blinds are very good heated and the facade not? And in Braunschweig, the reconstructed castle is complete covered with polystyrene and is completely blue, besides the columns. And the columns are not so cold as the facade. So I think the Braunschweig people now have energy to warm up the columns. I measure for myself, and I know what is temperature of the air, of the building. And here in my district city, I show the same house. In the morning, the sun is shining, and here it's covered with ETICS, it's the name, external thermal insulation covering system or compound system, and here it's the original facade by only bricks and rendering. And now we have 1116, and we have a cold masonry and a very hot ETICS, a very hot polystyrene coating. And then I come back in the midday It's 1342. Both facades have the same color, and then I come back in the evening, and in the evening the brick facade is completely warmed up, and the other is cool. What is the reason? It changes whole the day. And to say it shortly, the external compound system with polystyrene cannot store the temperature, and it will be very hot during the day and will get high temperature. And what we learned before, it has a high thermal expansion, and so it's very quickly rotten because water comes in. And in the evening it will cool down very much deeper than the air, so condense will come in and it's filled up with water. And that is a system our German government enforces all owners of building to do so, to coat all the buildings by external insulation. Completely crazy, and we have a bribed government from all the firms. And that's a reality in buildings with external insulation. All is rotten. And more, if you come to Germany, look for all the facades. They are rotten. And the government, by the building regulation, enforces us to do so. And if you will not do so, you will get a punishment of onto 50,000 euro. So it is in Germany. And our woodpeckers, they love it to be in Germany because they can inhabit in these facades. And also the worms will come in, and then the woodpeckers will find the worms in these insulation systems. So for the ecological point of view, it's quite good. And that's newly done, just 1 or 2 days after the scaffold come down. That is a new done thermal insulation. And you can see where will the next damages come next year. And then the night comes and the winter comes. And you will see every dovell, I think, what's the name? Yeah? Every nail you can see, because a nail is from steel and from resin. And it will warm up a little more than the thermal insulation. And so it will cool down not so far, and so it's a little bit warmer. And after 2-3 years, all is rotten, done by our government and profs which have no moral instinct. And then our experts, they know this situation. They say, oh, it's all too cold, too wet. We must do something against it. And what do? Something warm must be in the wall, they say. And then they start to give electrical heating in the insulation system of the facade. And they get patents for this, and they will heat up the too cool insulation facade. That do our scientists. Our science is completely rotten. And I read in internet, these people come to China and they found partners here to get all the insulation work also to northern China and other parts. And then, because it's so wet, a lot of biofilm will go there, and algae and fungi. And so it looks, after the first year, it looks very crazy, this facade. And they will safeguard it onto the first 5 years, because after this, no one will come to the firm to get money back. And so we found out they do very much poison in the coatings of this thermal insulation. And all our rivers are poisoned with these facades. That's the situation in Germany. And it's scandalous, and only very few media will cover this topic. So don't trust in German engineering, I say you. In America, they are very clever. Very clever. They found out the German insulation systems they have from Germans, they have their wooden buildings mantled in this thermal ACE. It's a name in America, external insulation finishing system. It is polystyrene. And all house will be rotten under. They had a big research. 90% are rotten. And in a lot of cases, the people are very sick in these houses. And then they ban, Oregon law bans ice barrier systems, often referred to as synthetic stucco. So they have legal bans against the German system. Please do the same. Follow the US. And in the inside, all is with mineral wool insulated, and it's filled up with algae and fungi. mushrooms, yes, and the ceilings, and everywhere we go and find the mineral wool, it's rotten, full of black mold. And the people will die. I exaggerate a little bit. You understand?
Yeah.
Please don't follow the German idiots. And look in the roofs. Now they found out too much wet situation. So we must have a barrier from plastic. So a synthetic barrier is given, but from outside comes enough humidity, and in the end, mushrooms over mushrooms. You Chinese, you like mushrooms. So go to Germany, you can import it. It's crazy, you must imagine. That's normal residential houses. And the government forces the people to do such things, and in the end, after some years, they all have rotten houses by government because of anxiousness of global warming, because it's the only reason. Global warming what will not exist. That is propaganda. Mineral wool, Wikipedia. It is in it, we have phenol resins and oils and the mold will eat. So they can find in mineral a lot of synthetics which they can eat. And so in the end, all is black. And that is the situation under our roofs, our flat roofs. All our flat roofs have insulation. And in all insulation we have condense because of the bad behavior of all the insulation material and the facades in all parts of the facade and of the roofs. And all is rotten. And everywhere the water will come in, not because the layers are bad, the upper layers, the reason is the frost and the water reactions in the insulation. So if you have only bituminous layers on concrete, it's much more better. But in Germany we are forced to have insulation, and this will make rotten all our roofs. In the end, it's burning, and we have a lot of burning cases where the people, whole families are dying in a lot of smog because we have no material which gives more poisonous smog in burning than the polystyrene. And nearly every week, every month, every year, we have several skyscrapers. That is Istanbul, for example. That is Moscow. Everywhere the skyscrapers will burn out by the reason of this burnable, inflammable insulation. And if we look to the costs, we can find out that the yearly costs per square meter to repair this system is over 10 euros more than a normal plastered facade. And we have a lot of damp air which comes in the insulation, and that's the rain.
The Fraunhofer Institute for Building Physics has measured the soaking of external thermal insulation by falling below the dew point many nights of the year in comparison with a facade of solid masonry. The red line is the dew point temperature. The black ones show of the surface. The line below is the external thermal insulation soaking up.
All the building physics is a hoax. All the building physics you will not trust. It comes from Germany, a land of a lot of hoax, of modern hoax. And this is the calculation system of the R value, and this is a reality. We measure it. That's a reality. The temperature in the wall never will meet the theory of the R value. So the whole R value based building physics is a poor hoax, and is only made to sell a lot of insulation. That's the reality of the facade.
The Governmental Research Institute for Agriculture measured the eastern, southern and western surface of a brick building a year long. The blue curve shows the air temperature. The real behavior of the facades never meet the building physics theory of the R value and never falls below the crucial dew point.
And we did some experiments to find out the temperature after 10 minutes burning on a 4 centimeter plate. This is mineral wool, this is wood and brick. and this is polystyrene. That's the temperature after 10 minutes having a 150 watt lamp on a 4 centimeter plate. That's my research team. This is the R value. You can see no effect after few centimeters. It's a hyperbole. And that is the reality of heating energy and the calculated heating energy. So it is nothing worse. All the building physics is nothing worse. It will not meet the reality. I say the building physics you must not need, because in building construction it will make all worse.
Here, the so-called Cambridge survey found out that thousands of calculated heating energy consumptions in Europe will never meet the reality. Before insulation, they are very much higher than the reality. After insulation, the real consumption is higher than the calculation. This mystery is called the pre-bound and rebound effect. But without any real data, these experts and the insulation industry claim the user of the building guilty. They incriminate the user to freeze in the not insulated building, and after insulation he shall exaggerate the heating to hell's temperature. A friend of mine, Professor Jens Fehrenberg, found out that only the average winter temperature is reigning the heating energy consumption. It's shown by the curve with mirrored temperature data from the right side. The colored energy graphs of the big buildings don't have any interaction with the date of the external insulation, the vertical green and red line. All energy consumptions follow only the winter temperature. This is the true knowledge of every grandma, he says. And external insulation causes no energy savings at all. Only in the hoaxed papers of the so-called experts.
We measure a lot of cases, and never the building physics will meet the reality.
Here we have the so-called GEWOS survey. This institute from Hamburg researched in the 90s the energy consumption of apartment houses with and without thermal insulation. And they found out every time if external thermal insulation, the building will need more energy consumption for the heating. So you see the red columns, these are the monolithic buildings without external thermal insulation. And the light columns show the heating consumption of the insulated buildings.
The Fraunhofer Institute knows this. In the 80s they measured a row of buildings, and they found out every time when external insulation is on the wall, it will need more heating energy. And they will not tell the public. It is secret.
The Fraunhofer survey extended over 3 years in the 80s. First they measured the buildings with different facades and different R values. The result is figured in the 3 big columns on the left. The blue columns show the R value, the red ones the heating energy consumption of the pure brick facades, the green ones of the insulated facades. Secondly, they built facades with the same R value with and without external insulation. First with white surface, then painted with dark brown color. In all cases, the insulated buildings consumed more heating energy for the same temperature level. A scandalous result, but hidden and neglected unto now. This German scam deceives the building construction on the whole world for the benefit of our chemical industry and their best friends in science, engineering, media and political administration.
Also in Finland,
never is there any coincidence between heating calculation and heating consumption in the reality.
Also in Austria, in all real experiments, they find out that the thermal insulation
will never meet the theory of the bribed modern building physics. We must know this if we want better, effective and really sustainable buildings. Also in South Tyrolia, the blue columns show the gap between calculated and measured heat energy consumption of the climate cubes. And the best, they had 2 cubes with different windows, 2 and 3 glassed, and it was the same consumption. And why? Because the whole building physics for the window is also the pure scam. They did not know that there is a solar energy outside the window and it brings a lot of free energy into the room. So, what comes in during the day will often be more than the equivalent of the losses in the night. And if there is a blind and it's closed, you will have an absolutely optimum of saving heating energy. Also with a single glazed window. And that's the method of our grandparents.
also in Switzerland. That is a house with polystyrene, the room. And this is the heating of the only brick house. So don't trust the building physics. The Americans, they know green approved buildings using more energy. The Americans know. In our media, they don't know. A little to the heating.
We see left above the convectional heating and right above the floor heating. Both heating systems will make a typhoon of dust in the room, and the dust will hurt for long and will make dirty the whole room. The idea is to have a better radiation and not so much convectional heating. So you see below the system of radiation heating and how we do it in the practice. And what you can see also, we have the tubes, the pipes of warm water on the wall, not inside. This saves a lot of heating energy. And we have not a shutdown of heating during the night. This also can save on to 30% of heating energy consumption.
The Keiner slot in Sweden, no heating will make a lot of damage in our region, maybe also in northern part of China.
Here we have the castle of Brühl near Bonn. Formerly the castle for official reception of our government for foreign guests. Your president, Jiang Zemin, was there just 13 years ago. The suboptimal convectional heating method caused many damages at the fascinating Chinois and other Baroque and Rococo interior. In future, will they follow our recommendations for a conservational heating by more infrared radiation with electrical heating systems, as we planned in a pilot project for the following castle near Würzburg?
And we have projects where we have a little bit heating only to protect the buildings against such corrosion.
By thermal and hygraic short time change of the indoor climate.
So in my office we also do heating technology and electricity.
Also in churches we find a heavy deterioration of the interior carvings and paintings, but also of the organ by cracking and molding, caused by indoor climate problems. Our solution for improving the indoor climate is economic, and its installation does not hurt the building fabric so much as common heating systems. You can detect climate smoothing on this chart. The upper graphs represent the air humidity, the lower the room temperature. On the left side before, on the right side after our installation.
That is the details we need to repair old houses. That is the drafting we need. Show every tube how it goes through the late Gothic construction. This is repair, and this is repair. And also this can be repair if it's a more simplest way to have a rescue for the given situation. And also this can be repair, only a line wash and nothing more. For a museum it's okay. And if some new things come like this or like this, it must not look like coming directly from the Mars. In the end, if we have worked very hard, not our nose will be gilded, but our instruments. In the end, a good architect, it is Bernini, I think you know. And he is lying here under this tombstone, Laurentius Bernini, and he is humble, is he writing, a humble architect. That is the finish. And the Holy Barbara, the Saint Barbara, it is a patron of us building workers, of us architects, of us craftsmen. She is saying to the people, only stone, only lime mortar, and no external insulation. Thank you very much.
You know, we just added the insulation on this building using a German product. And this Konrad just gave us a very interesting, in detail, and valuable lecture. And it's a very long lecture. At last, I think I only remember 3 points. The first one is be smart. Be a smart architect and be a smart restorer. And the second thing is find the key problem. And the third is find a proper solution. And any questions? I think it's actually it's a lecture on conservation, design, and the technology. Yeah.
Yeah. All answers are given.
I have a question.
Yes.
Can you recommend one or several books to support your designing or planning?
I understand your question. And I must tell you,
Yeah.
this question, very often I get with email. Because on my website, I sell on a very little site my service as expert only by telephone calls. And it costs 1 hour 180 euro. And the people read and they say, oh, it's much money. And so they, where is a book where I can read all your knowledge? And a book cannot cost 180. So I have no books. I have written a book. I have written a book, okay. And this book is from 2007. You will find on my website. But I will not recommend you because what I said today is more updated and more detailed than I can give in a book. We have a very good book from just 3 weeks ago, that expert, it's Professor Klaus Meyer, and he did a lot of books, but the best one is Richtig Bauen, and it's in the Expert Verlag. You will also find on my website this good book and other books about heating problems, and he is the only expert in Germany which over 30 years goes against the building physics, the wrong building physics, and shows the correct. And we, when we do heating, we go with the corrected formulas of Professor Meyer, and we will meet the reality much more better. So, Professor Klaus Meyer, Richtig Bauen. But it's only the theoretical problem. You cannot read how to do this and this, but it is general critics to the hoaxed building physics. And I think it's very important, because he shows all the problems, what they have in calculating heating and humidity problems of building materials and things like this. And for the finish, in my office I have since 1988 a lot of volunteers from other countries. And if there is a Chinese one, he can come to me, he can live with me and my colleagues, and he can work with me for 1 year or so. I can manage the permissions and all the things. That is my invitation. If there is some interest, no problem. But I'm not university, I'm only a simple self-employed architect. I thank you for your audience, and I know it was a hard thing. Maybe you can find me in the internet. I have also Chinese pages done by Chinese students, not by Google. Okay.